Good morning, folks. Mr. Chandler here. Going to go over the graphing motion quiz 1 we took yesterday, which was Friday. Today's Saturday. So let's hop into it and go through the quiz so you know how you did and can see how to correctly solve these problems. All right. Let's go. All right. So number 1, we had a velocity time graph, and I asked you to describe the motion of the object with words, right, using terms like velocity, direction, displacement, etc. So I want you to see here we have a constant velocity initially of positive 2. So I might say something like an object. Maybe I don't want to type this instead of writing it because you probably can't read my handwriting anyway. So I'll insert a text box here. And then we'll do, whoa, that's not what I want exactly. Moving all over the place. That's, okay. So I'll say an object moves with constant positive velocity because it is moving in the positive direction there for 2 seconds. The object stops for 2 seconds. Then the object moves in the negative direction at a constant velocity for 2 seconds. And you could give me the velocities too, is positive at 2 meters a second, negative at 2 meters a second. If you look at the area under the curves here, right, this area is a box, a 2 by 2 box, so it's 4. This is also a 2 by 2 box, but it's -4, right? The displacement, remember the displacement is the area under the curve or the area between the line of the graph and the x-axis. So if you take these two areas, they're both rectangles. This is +4, this is -4. Those you could have also told me that the displacement of the object is 0 because it goes +4 and then -4 back to where it started. So that could have been an answer. There's lots of ways you could have told me that. In other words, you could have used different vocabulary, but that's the gist of it there. We go at a constant speed forward, we stop, and then we go back to where we started in the negative direction. Constant speed the whole time. So yeah, that's number 1. Let's go to number 2. On the axis provided, draw and label quantitative velocity time graphs for objects A and B. Well, I'm not gonna draw the graphs like when it says quantitative graph, that means you're supposed to like label it and have a precise scale and everything. I'm not gonna do that right now because it would take too long, but I'll show you what the shape of the graph should look like. So let's do blue first. So let me get my blue. Let me get a blue pen here. I'll do the graph A first. And so we have no slope here. It's a position time graph. Always got to look at pay attention to the axes, position time graphs. So we have no slope here. It's a horizontal line. That means we have no velocity. So I'm going to make this a velocity time graph. It's velocity in meters a second. It's going to be time over here. Time in seconds. And so since I have no slope, that means I have no velocity. So I'm going to, it's like about 5 seconds there. Goes to the 5 second mark. So for 5 seconds, and I'll make this 2, 4, 6, 8, 10. That way I get all my time in there, right? I use the whole graph. I'm not going to just use part of the graph. I'm going to use the whole thing. For 5 seconds, this thing has no velocity at all. So halfway here, this thing it's on the x-axis. There is no velocity. Okay, so make sure that shows up on the screen there. Now, suddenly we begin to move forward. We have some positive velocity here. What's the slope of this line? Looks like it goes up 1, over 1. And then it goes from here, it goes up a box, over 1 box, up 1 box, over a box, up a box, over a box. So it's looking like it goes, oh no, yeah, up a box, over a box, yeah, so it's going up 2, over 2, up 2, over 2. Oh no, wait, no, this is by 1. So each box here is 1, each box here, oh no, okay, it's going up by 1. So 1, 1, 1, okay. Sorry, for a second there I thought the boxes were 2 each, but they're only 1 each. So up 1, over 1, up 1, over 1, up 1, over 1. So the slope is 1. So if the slope is 1, the velocity is also 1. So this is a velocity time graph. I'm going to label this 1, 2, and 3 here on my y-axis. So I'll do -1, -2, -3 here. So we suddenly become -1. I'm going to draw a little dotted line there to represent we suddenly become a velocity of 1. And it's constant. The slope is constant, so is the velocity. So we should have a flat line there just like that, showing us a velocity of 1 for the rest of the graph. Object B, this is object A. I'll put an A there. Actually, I won't label. I'll label over here. All right, object B there. Going to go in orange. All right, so again, the slope here is the velocity. The slope here looks like it's going up how much? Starting at -6, goes up to -3, and then up to 0. So going up 3 over 1, up 3 over 1. So that's going to be a slope of +3. So I'm going to have +3 velocity for 2 seconds. So I'm +3 for 2 seconds. So here's my start of my graph at the very top up here from on my scale, the way I did it. Your scale might have been different. It's okay as long as you use most of the space provided to you. And then look, what's the slope here? The slope's going down, so we know we're going to be negative somewhere. I'm going to draw my line down here. I think it's -1 or so, or maybe -2. Let's see. Down, or I should say over 2. Sorry, I should say, let's go from here. I'm going to go down, how much? Down 4 over 4. So it is -1. Down 4 over 4. So my slope is down 4 over 4. So rise over run there is going to be -1. So we go down to here, and I'm going to, and then it looks like I'm -1 for 4 seconds from 2 to 6. So a -1 slope here. And then the slope on the last part of this graph, this section right here, there is no slope, it's 0, so that means I have no velocity. So I go back up to the 0 line, and I have no velocity right there. So remember the slopes on this graph over here, the slopes there have to match the value of the y-axis on my velocity time graph. So again, look at the blue graph real quick. The blue graph, this section here was no slope, so I had no velocity. I'm at the 0. Then I had a slope of +1 here, so I had a value of my graph being +1. For the orange graph, I had a slope of +3 here, so I started at my velocity of +3 for 2 seconds. Then I had a slope of -1, so I went down here to -1, had a -1, but the value of my graph was -1 for 4 seconds. And then I had no slope right here, so I have a velocity of 0 for the remainder of the graph right there. I'm on the 0 line there. So hopefully you can follow those steps and see what you did wrong, or maybe celebrate if you got it right. Shown below is the velocity to first time graph for an object. All right, so now I'm going to do the flip. Now I'm giving you the velocity time. I want you to draw the position time graph. I'm going to get back to my black marker. And let's see, the velocity is 1 for it looks like 5 seconds. So I'm going to have a slope of, first of all, I'm going to go about 13 seconds here on my x-axis. So I'm going to go by 2. So I'll go 2, 4, 6, 8, 10. It's going to be 12 right there. And then looks like my velocity is in +1, and then 0, and then -2. So, all right, I'll start at. I'll start at the origin. Well, I guess I can start at the origin. That's fine. 0, and I'm gonna go up. See, for 5 seconds, up by 1. So I'm gonna go by 2s on here. I don't know how tall this graph's gonna be. I'm gonna make up my scale just to make sure it fits. So I'll go by 2s. So 2, 4, 6, 8. And you tell that because this is by hand, is not exactly precise, but it's okay. And yours won't be either, and that's okay because I didn't give you a nice grid like I did up here. And that's fine. I'm really looking for the shape on this one. So we have a +1 velocity, which means my slope should be +1 for 5 seconds. So I'm going to go up 5 over 5. So right about here-ish. Right about there on my janky graph here. I'm going to draw that. Now I have no velocity here, right? So I have no slope for the next 5 seconds. So to 10. No slope to the 10 mark, the 10 time there. Right about here. And then suddenly I have -2 velocity for the last, looks like, actually it doesn't quite complete the 13 there, but I didn't notice that, but we'll just say for 3 seconds. So for 3 seconds, let me put 14 on here. So for the next 3 seconds, I have a -2 slope. So I'm at 5. I'm gonna go down 2 over 1, down 2 over 1, down 1 over 1. So I should end up at 13. Let's see. So down. I'm at 5. Going down to 3 over. Down to 3 on the y-axis and over 1, and then down 3 over 1. Should be at 1 and 12, and then down, and then like right here at 13 seconds. Okay, close enough. So this is the shape of the graph I was looking for. So looking for a positive slope here, a no slope, and then a negative slope. Now this line should be steeper. Right, it should be steeper than this line because the velocity here is -2, so the magnitude was 2, and the velocity here is only 1. So this line over here should be steeper. That's what I'm looking for here, really, on that one. What is the final change of position or displacement of the graph? Well, if you shade in the area, the area of the curve is displacement. This is a rectangle here. This is a rectangle of 5 by 1, so this is positive 5. This is a rectangle. Again, I didn't realize this. It looks like it stops at 12 and a half mark, but so I guess I'll do 12 and a half, but I didn't realize that until just now. So, well, if you did the 13, that's okay too. I won't take off for that. So this is -2. It's a rectangle of -2 length by 2.5 width, which is going to be -5 also. So the displacement is going to be 0. Or if you took this line out to 13 and did like this, you might have a different answer, and that's okay. If you did that, then you have -6 here, and your answer would be -1 here. So I'll take 0 or -1. I think technically the answer should be 0, but I'll take either answer. All right, next question. All right, here we have a position time graph, and it's got some curviness to this one. And I ask you to describe the motion of the object. Make sure to use your physics vocabulary again. Reference the points labeled A, B, and C on the graph. So really, I want you to tell me what's happening in each section. So here, I was going to talk about this and write it out a little bit, but I'm not going to type a paragraph again. What's happening here? Well, the line is getting steeper in the negative direction. You see how the tangent lines are getting more steep? So we are speeding up, getting steeper, so we're speeding up. In what direction? In the negative direction, because the slopes of the line are going down on the graph, which is towards a negative direction. Speeding up in a negative direction. Now on B, we suddenly start to slow down. See, the graph starts to get flatter, right? So we slow down and stop, actually. Slow down and stop at B. And then here at C, we sped up again. We speed up in a positive direction. And then continue at a constant speed. Okay. So, yeah, you see here how we speed up here. We start to get steeper. But in this line segment here, it's pretty much straight line. You know, it's at an angle, but it's not curving. Straight line on a position time graph means that we're going at a constant speed. So we speed up, we gain some speed, and then we start going at a constant velocity at some point in the positive direction. So that's what I was looking for there. Some sort of description of that motion. And then asked you to, below the graph, sketch what the graph of velocity versus time would look like. And when it says sketch, that really just means show me the shape of this. So let's see, speeding up in the negative direction. What does that look like on a velocity time graph? Speeding up in the negative direction means we're doing this, okay? So remember our values here are 0, 1, 2. I'll make up some numbers just to show you. Now, our numbers are getting bigger here, right, in the negative direction. They're negative, but they're getting larger. 1, -2, -3. The negative sign just means direction, but the numbers themselves are getting bigger. 1, 2, 3. So we're speeding up negative direction. Then suddenly we slow down and stop, which means we're going to go back to the 0, right? We go back to 0. We have no velocity for a few seconds while this line is flat. And then we speed up in the positive direction, and then we continue with the positive velocity in the positive direction. So we speed up in the positive direction, so that's the line going up. And then constant velocity at the end here, where the line is straight here, means we got a flat line here, constant speed. All right, and then there was a bonus one here about the acceleration. This one real quick will be, we have remember this is just a slope, right? The slope of velocity time graph is the acceleration. So we have negative slope here. So some negative, let me make my thin thicker so we can see this. Some negative slope here for a few seconds, and then we have a positive slope, so it would suddenly become positive like this. Then we have no acceleration here. We're at 0, a flat line. So we got a 0. And then we're going to have some positive slope here. So we go up. If I can erase that. Up here to the positive area again. And then when we're at a constant speed here, there's no slope there either, so we go back down to 0. And that's why this was a bonus, because if this one was pretty hard to kind of conceptualize, so that's why it was a bonus point. It's not going to count off or anything really. Just see if you can do it. If not, no worries. Okay, number 4 was a velocity time graph. and ask you some math questions here about this graph. So the first thing I wanted to know was, what is the object acceleration from t equals 0 to t equals 1.5? So that's from t equals 0 is here, right? Because that's where the time 0 is. So from that point up to the 1.5 second mark, which is here, to this point here. So we're going from this point to this point. What is the acceleration? This is a velocity time graph. Velocity time. So that means this acceleration is the slope of the graph. It is the slope. So let's get my calculator here. And we'll find out what the slope is. Okay, so we start at rise over run, right? So change in y over change in x. Change in y is going to be, let's see, we start at -1 and go up 1, 2, up 3. So 3 divided by, and the change in time goes from 1 to 1.5. So 3 over 1.5. And of course that's going to be 2. So my acceleration should have been 2 meters per second squared. What is the displacement of the object from t equals 0 to t equals 4.5? So that's the whole graph. So remember, displacement is the area under the curve. We have this little bit of area here in the negative region to start with. So that's going to be negative displacement. And then we have this big area here. I'm going to divide it into triangle, rectangle, triangle. Because I don't know what shape that makes. If I don't do that, and I don't know geometry, area, equations, so we'll divide it into 3 little chunks there. Well, 4 chunks, I guess, if you count the first one, which we do. So area to the curve, again, means the area between the x-axis and the line of the graph. This first little triangle is going to be actually negative displacement. So let's see, area of a triangle is 1/2 base times height. So the base is 1/2, and the height is -1. So that's -1 times 1/2 is 1/2. A half times half is going to be 1/4, right, or 0.25. So the first little area is going to be -0.25. I'm going to add up the next 3 sections, right, because they're all going to be positive because they're above the x-axis. So this one here, this area was -0.25. And again, that's just the base, which is 1/2. I'll write that out. 1/2 times the height, which is -1. Times 1/2 again, right? It's 1/2 base times height. So that's going to be -0.25. Now let's do this triangle right here. 1/2 base times height. So 1/2 base times height is my formula. The base looks like is 1. From 1/2 to 1.5 is 1. And then we're going to go up 2. It looks like, right, from 0 up to 2. So it's going to be 1/2 times 1 times 2. That's like going to be a +1, right? 1 times 2 is 2. Times 1/2 is going to be 1. It's positive 1 there. This is a rectangle, so it's going to be just base times height. And again, we have a base of 1, a height of 2. 2 times 1 is going to be a +2. And then this area over here is a triangle where the base is a little longer, this one. Let's see, the base goes from 2.5 to 4.5, so the base is 2. The height is 2. That's 4, but it's 1/2 base times height. So it's going to be 2 times 2 times 1/2. So that'll be 2, right? 2 times 2 is 4, times 1/2 is 2. So +2. Then we add it all up. So 2 plus 2 is 4, plus 1 is 5, minus 1/4, it's going to be 4.75. So my answer is going to be 4.75 meters of displacement. All right, we moved 0.475 meters in the positive direction. Briefly describe the motion of the object in your own words. Okay, I'm just going to talk about this. I'm getting tired of writing. This videos, I don't want the video to be too long. So here we start off, and we're going in the negative direction initially with the velocity time graph. We have negative velocities here, but we're slowing down, right? Our number is going from -1 here to a -1/2, and then we get to 0. That means we stop. So we're going in the negative direction initially, but we're slowing down. We stop for a moment. We turn around. That's important here. We cross the x-axis. That means we turn around. Now we're going in the positive direction. We're speeding up. Speeding up, speeding up, speeding up, speeding up, speeding up in the positive direction. Suddenly, we stop speeding up. We're still moving, but now we're going to go at a constant speed for 2 seconds. Over to here. Let me erase all those stuff and see what I'm doing. All right, and then once we get to here, we've gone to the constant velocity from this part of the graph. Now we're going to slow down again. Slowing down 2 meters a second, 1.5, 1.5, and now we're at 0, and we've stopped back at 0 velocity. So again, we start off with a negative velocity here. Start off with negative velocity down here. We actually slow down, negative a half, negative a quarter. Now we're at 0. We turn around. Now we're going the positive direction. We have positive velocity values over here. We're speeding up, half, 1, 1.5, 2. We speed up, speed up. Suddenly we stop speeding up. Now we're going to go to constant velocity for 2 seconds. Still moving forward, just not speeding up anymore. And then we slow down. 1.5 meters a second, 1 meter a second of velocity, a half meter a second, and then we stop at velocity 0 right there at the end. Okay. All right, and last we had some math problems here. Jorge is sitting in a red light in his car. Light goes green. He accelerates at a rate of 3 meters per second squared for 5 seconds. How far does Jorge travel during this 5-second period? So I wanted you to try to use that guess method where you figure out, well, what does the problem tell me? It tells me my acceleration is 3. It tells me my time is 5 seconds. My initial velocity is 0 because I'm sitting in my car. And then the unknown is delta x. Well, what is the displacement? And I'm trying to find, right? How far do I go at the displacement? Then I'm going to pick an equation. I'm going to use delta x. The second equation in your formula charge, 1/2 at squared plus v naught t. V naught is 0, so 0 times t is 0. It's going to just go away. Kind of nice. And then we know the rest of these numbers. Delta x is going to be 1/2. A was 3. T was 5. 5 squared is 25. Plug all that in. And we get, I don't know, 47 something. 25. I like how the calculator, the ROM, like it goes to sleep, even though it's not a real calculator. 25 times 3. And divide that by 2. 37.5. Okay. 37.5 meters. If Jorge kept accelerating at a rate of 3 meters per second squared, how long would it take him to go 1 kilometer? Or this is a little trickier. So if he keeps accelerating for 3 meters a second, he just keeps the pedal down, right? He just keeps accelerating, breaks all the speed limits. How long would it take him to go 1 kilometer? All right, and then I'll give you kilometers, 1,000 meters, right? So now we're going to say, all right, if my displacement, all right, is 1,000 meters, and my velocity initial is still 0, my acceleration is 3, and what my time, how long would it take to do this? How long would it take to go 1,000 meters? I'm going to use the same equation, delta x equals 1/2 at squared plus v naught t. Again, v naught is 0, so this term here goes away because 0 times t is 0. It's just going to go bye-bye, right? Delta x then, which was, I'm going to rearrange the equation for t, right? I'm going to derive an equation for t. Just going to move stuff around. So I'm going to times 2 both sides, get rid of that half. Cancels the half out. I'm going to divide by a both sides, get rid of the a here. So I got 2 delta x over a. I'm going to square root it to get rid of the squared sign over here. So it's going to be equal to t. Now I'm going to plug in my numbers. So t will equal square root of 2 times 1,000, because that was delta x. My lights just went off. Spookiness. Over a, which was 3. And I get my answer. So I will put my calculator up. And we're going to do the square root of 2,000. It's 2 times 1,000, right? Over 3. And it gives you some lovely fraction. But I don't want a fraction. I want come on, calculator. Give me the answer in... How do you convert it? I forgot how to convert it to... Well, you can really give me that for... All right, fine. Here, you know what calculator you want to be like that? 8617 divided by 8467. There you go, 25.8. I don't know why it gives me the answer in this weird, this giant fraction. 25.8 seconds. 25. That's actually really fast. But then again, you know, you just keep accelerating. Your velocity is gonna get really fast, really quick. So doesn't seem too surprising, I guess, to go 1,000 kilometers. Unless I messed up somewhere, did I? No, I don't think so. Let's see, times 2 both sides. Divide by a, square root. No. All right. Last question. Using your answer from part B, what would Jorge's speed be when he reaches the 1 kilometer displacement? All right, so now we're going to use that first kinematic equation on your formula charts. That was v equals v naught plus AT. Now we know what t is, right? It's 25.8. And we know a, which was 3. Our initial velocity, remember, was 0. So we're going to plug in the numbers and find out what my final velocity was. So v naught plus 0 plus a was 3. T is 25.8. And I'm going to get my answer here. This number times 3. 77.5 meters per second. Let's make sure I did that other fraction correctly. Okay, yeah, I did right. Let's make sure. So there you go. It's going 77.5 meters a second, which is really, 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 really fast. That's like speeding bullet speed. So Jorge, hit the brakes, bud. Okay, guys, that's the whole quiz. Hope that was helpful. You go through at your own pace, watch each piece. If you still have questions or concerns, comments, please come see me. I know this seems like a lot at first, but you're going to keep practicing and you're going to be okay. It's a long journey, and we just have begun. So don't worry about it. Everything seems crazy hard right now. That's normal, and you'll be all right. All right? So see you guys next time, I guess. Bye-bye.